Okay, we are all set. Over to you, Pavan. The lecture stage is all yours now.
Hey, thank you. So let me share my screen. Shall I proceed and share my screen?
Yes, sir, you can.
Okay, so hope you are all doing well and excited for the next 1 hour of this data hour. So in this 1 hour, I'm going to start with the topic, the data engineering in a nutshell, and the agenda for this total meeting is to just briefly go through what is ETL and what is ELT, and how this is different from data engineering and data pipeline, or how these two are related in other way. And the so my opinion is, you might get resources, how to do and what to do, but why we need to do and what is the architecture looks like is a little bit difficult to understand if you are from outside the IT industry. So in this session, my focus will be more on the architecture side of data pipeline in industrial standards. So yeah, so this is the context of this session. So I'll be explaining the one of the best data architectures I have been through till now. So I'm so excited to introduce an industry level data architecture to all of you. So before I jump into the topic, let me introduce myself. I'm Pavan Kumar, as you already know, and I have around 8 years of experience in IT, and most of the my career is handling data. I started my career in ADP as a ETL developer, and then I worked for Infosys as a data engineer, and then I worked for Altimetric, where I learned a lot to know how the data architecture help in maintaining and doing some quality data processing and adding value to the business. And then now I'm in Microsoft, which is my dream organization. I'm sure most of you are also having Microsoft as a target, and I would love to assist you in this session, through this session. And also, if you have any any questions or any tips you need to ask me, you can feel free to drop a message, and I would love to answer your questions. And my area of expertise into data engineering and handling big data. Basically, I worked on different ETLs like Talent, Informatica as well, and multiple different tech stacks involving handling big data. And I'm an enthusiast enthusiast to participate in hackathons. So before I finished my graduation, I participated in 2 hackathons, and I won one Windows Microsoft hackathon called Japan. So that's when my love towards programming and coding began, and here I am. So then in my tenure during Infosys, I participated in another 2 hackathons and one of the global hackathons Infosys conducts every year. And then in last year also, I participated in one of the hackathons conducted by Microsoft. My belief is that um, to learn any technology or anything, instead of just going through some videos online or exploring something, it will be uh, it will add more sense if you take up one project and implement that by yourself. And then the knowledge acquired during the project implementation, uh, you exhibit those skills in the hackathon. So that gives you a confidence to believe in yourself, and also you feel more confident to solve any problem going forward. So that's one thing I would recommend you to work on some projects rather than just some random stuff. Pick up a project and solve that, and then if there is any chance, go ahead and participate in hackathons. And my hobbies, when I'm free, I like to trek. I didn't do much trekking, but hopefully I'll do more often, at least from now. So yeah, so that's pretty much about me. And then let's dive into the data engineering, the core concept, what we are going to cover during this data hour. Data engineering. So we may call data engineer now, data engineering now, ETL or ELT or whatever in the legacy systems. So the fundamental operation, what we do as part of this is simple. You have data in your source and you need to port the data into the destination. But as data is growing more these days, you might heard of famous V's in big data. If you heard of big data term, the velocity, variety, and veracity, and the volume. So because of all these three factors, ETL is not sufficient to handle the data. And as time passing, the way business is evolving is also changing. So to help our business partners, business to grow, uh, as a data scientist and business analyst and machine learning algorithms, whatever, to get better insights from the raw data which is coming from our source, we need to do some data cleansing, data enrichment, and do some processing on top of it. And also we need to govern the data to make it available for these data scientists and the business analysts and so forth. So for that we need to have some meaningful data. So we as a data engineer, we will do this data cleansing, and we add some meaning to the raw data which is coming from source. The sources may be different. Like in legacy systems, we used to handle only the formatted data, like structured data, like comma separated files or tab separated files, maybe some tables or flat files, or to some extent, if you say semi-structured data like JSON files or XML files. But the volume we used to handle is comparatively less, but now it is huge chunk of data we are going to process. And the data formats also different, and we are handling structured, unstructured, and semi-structured data, everything in one place. So for that, earlier we used to have a data warehouse, and now from data warehouse we are going towards data lake. And then so it's something like we are following the data warehouse concepts, but in a different way, by adopting the velocity and variety of the data we are going to process. So it is kind of hybrid of data lake and data warehouse, and uh, things like that. So let me start with ETL and ELT and the fundamentals of ETL and ELTs. So when I say ETL, it is extract, transform, and load. So whatever data sources we have, maybe let's take a website, and we are trying to get some log data from the website. Mostly this ELT is a batch processing. So we schedule a data, we schedule a job for maybe once in a day, like every 12 a.m. kind of time. we read our website data and check how many users are active yesterday, and different regions from I mean the to know the users are from which region and stuff. So kind of any analytics to do that. We used to schedule a job at a certain time, and this used to run every scheduled time. So this is a batch processing. And what happens in ETL, we extract the data from the data source. Maybe it is in a relational database which dumps data from website to database, the transactional database we call OLTP. And then from that from the database are the flat files, are the JSON files, as I mentioned, the semi-structured data. We process that data while we port to the destination or our target data warehouse. So this data warehouse, we call that kind of analytics OLAP, for doing some analysis and get them insights from that, and further we do also reporting out of that analytics database. So the key here is we do the data transformation in memory. Let's take an example of ETL tool like Talent. So what we do, we will have some components in Talent, like to connect to a data source. We give the data source details, and we will give some credentials to connect to the data source. Maybe let's take one database like MS SQL. So our SQL Server is our data source. We give all the required credentials and read the data, and also do some transformations in between these two source and target stages. We apply some business logic, like if we want to join two tables and get some aggregation values and stuff. So any kind of business logic we'll apply on the fly in memory, and then we load the data into our target database. So this is ETL. And ELT in on the other hand is something like, before we do any transformations in memory, we just load the data from the source to the target database, and in the database we do some data transformations and store it in another database. So in here we can call some we will have some staging area to load our extract and load our data to data warehouse, and then do some transformations and put it in our final or usage or publish layer. So this is the basic or fundamental differences. So here uh, what is important is we need to have some in-memory good in-memory operation capacity to do extraction and the transformations in the tool. And here we depend on some solutions like MS SQL, or in modern cloud-based database like Snowflake. Let's take an example. So in Snowflake suggest this ELT. So what we generally do, for suppose let's suppose we have some our source data in our S3 buckets per se, or in Azure blobs, let's say. So what Snowflake does is it will create a metadata on top of this what do you say, the source data files, maybe JSON files. It supports flat files, or any XML files, whatever file formats are there. We just define the um, DDLs, and we give the location of that object store, and then we are ready to read the data as a table, and then we apply any transformations on top of the data, and do the then publish it to the final or the publishing database. And from the publishing database, we visualize the data, or we report the data, based on the business requirements. So this is the fundamental difference between ETL and ELT. When we compare these two, data engineering, other data pipelines, I would say ETL or ELT are a part, a sub part of the data engineering, because it supports this mechanism, supports only the limited data, and mostly for batch data processing. But now we are also getting data in real time, and we want to do the analysis on the live data and publish the reports. If not real time, we are targeting for near real time at least. So for that, we adopt some kind of messaging queues like Apache Kafka, or event hubs, or Kinesis for AWS, many other messaging queues, and uh, to do some data processing on the fly while you get the data. We're then and there doing some data analytics and publishing it to the end user, or the business decision makers, to have a clarity on what to do and how to go further to increase the business. So that is a little difference between these two things. So the final conclusion from my perspective is ETL and the ELT are the sub parts of data engineering. So let's take an example, industry standard architecture. I would say this is one of the architectures I worked on to maintain the to do the data cleansing and enrich the data and the process based on the business rules. And also the important thing is to govern the data. So this architecture support each and everything which with all the best practices. And also I will walk you through with another architecture. We call it as a Lambda architecture, where we combine the best two worlds, like batch data processing and also the real-time data processing. So yeah, so we do the batch processing and also get the data from the real-time sources like Kafka, and do the processing and publish it. So that is we call Lambda architecture. So yeah, if you see, there are multiple layers here. So the first one, we see the data source. As we know, the point A, let's consider the data source, and the outbound or the visualize layer here. This is our destination. Like this visualize layer or the access layer are the outbound data warehouses, or kind of targets. So between these 2 points, we are doing a lot of data processing. Maybe let's take step one by one. So from the data source, we need to have one tool to push the data to our data lake. Let's say this. So here we can have two different mechanisms. So this is let's consider the environment between these two endpoints, the data source and the access layer. These two endpoints, between these two is our environment, which we will have some control as a data engineer. So to get the data from their environment, like our upstream environment, when I say upstream, that is our data source, and downstream is the data consumers, which downstream is the data consumers who consumes the data we prepared out of all the data processing mechanisms we do. So data source is there, and we need to either we pull the data, or the data source, the data generators push the data to our layer. So first layer is a sense layer. I'm calling this as a sense layer. And in different architectures, you may be familiar calling that a bronze, silver, and gold data. So here the bronze layer, or the sense layer, is to have the raw data. Basically, in this sense layer, you can see there are three buckets of data. I think you are familiar with these things. So let me so these are the S3 buckets. S3 bucket is nothing but an object store, which will provide you by AWS. And in the similar way, you will have blob storage in Azure. So any object store, because why we are choosing object store is because object store can store any kind of data, either be it structured data, semi-structured data, or unstructured data. uh, and then while you do processing, you can create, for suppose you want to see that unstructured data also in the tabular format. So once you get your data into your sense layer, then you can apply metadata on top of that, and you can query the unstructured data also, just like your structured data, which we generally call that RDBMS system. So like just like a tabular form. So yeah, so here we can have two mechanisms, either push or pull. So in this case, this is a push mechanism. So from SAP data source or SQL server, um, either our team as a data engineer, we if we are connecting to, as a data engineer, if I am connecting to the source data and pushing the data to our pulling the data to our layer, that is pull mechanism. And push mechanism is something, so this team, this data source generator, the data generators team will do this for us. And main important thing to remember here is the sanity checks. Uh, so while we if we are pulling the data, we are good. We know what data we are pulling, and whether that is accurate or not. We know that we know that when we are pulling the data, because it is in our control. But when the push happens, the best practice is to have a metadata besides the data they send. So when I say metadata, for suppose we are getting a JSON file or a Parquet file. Parquet file is nothing but an optimized file format, which will give you a flexibility to query faster. It will have multiple features, like it stores the aggregations in a block format. So when you are trying to get some aggregation, like some of the fields, yeah, for suppose we want to do some of the sales in the table, right? So it will have the sum in one of the blocks, and it will not it will not scan through all the rows available in the table. So instead of that, it will get the sum from that block. Okay, so coming back to here. So when I say the metadata for this data is that when our source system is pushing the data from their database to our data lake, we need to know how many records they have sent and what is the schema for that. So if we get these details, it will be easier for us, and also we are sure that there is no data loss. So what we do when they push the data, besides this metadata file, maybe let's consider this metadata file as a metadata JSON file. So every data load our upstream does, it will generate a data file. Also it push the data source will also pushes the metadata file. So details of this data file will be stored in the metadata file. So suppose they are sending 1,000 rows, and they will mention the number of rows they sent in the metadata file as 1,000. And what is the schema of this file? When I say schema, what are the fields and what is the data type of each and every fields? So this is directly come to our pre-landing zone. So data source is there, and using ingestion tool like DataHour or even Databricks, we just ingest the data to the target layer. In this data flow, we ingest the data from DataHour to pre-landing zone, and from pre-landing zone to landing zone, what we do is we do this sanity checks. So to make sure the data is accurate from the source to our environment. So what we do, once we read the data file, we will make sure this data is matching all the details which is maintained in the metadata file. So we check for whether the count of this data file is matching with the data provided in the metadata file. So as I explained, so they send some 1,000 rows of data. We try to match the data we received is 1,000, and that is matching with the metadata. So if and only if this matches, and also we do the schema check, how many fields are there and what is the data type of each and every field. So we do this matching. If and only if this matches as per the metadata, then only we do the next data processing. Otherwise we just alert the source data team, saying that we didn't receive the data as per the manifest file, or I mean metadata file. So so we are saving all this processing, because as per the metadata file, we are supposed to get 1,000 rows, but we are seeing some 900 rows. So in that case, we are missing the 100 rows, and it doesn't make any sense to partially process the data instead of processing the whole data, which is generated by our source team. So that is the first sanity checks we do. And then from landing to we will excuse me, from landing zone to we send the data to landing merge. So this all processing we do using some data processing engine like Databricks, or Spark in the on-premise systems. So Databricks is nothing but Spark in the cloud basically. So we are using Databricks to do the data processing here. So what we do in landing zone to landing merge, here we will have two different mechanisms. Like either this is a truncate and load kind of data. For suppose I have some fact data or dimensions. I believe dimensions are nothing but the names of the are the units of the data, and facts are the measures of the data. For suppose how many products are sold today, that is a fact. And what is what is that product? So this product will be stored in a master data, or in a dimension table with some ID being generated. So we associate this product name with an ID, and we refer that ID as a surrogate key we call, or natural key. The name is a natural key, and this ID is a surrogate key. Of different data warehousing concepts. So anyway, so here what we are doing is either we truncate and load the data, or we can even have some incremental data. When I say incremental data or the delta data, we need to we always see some IDs are coming every day. Like if let's take an example of any shopping website. So what I want to know is how many shirts or pants are sold today. So these might have the same IDs, right? Like let's assume a pant having ID as 1 are sold 10 yesterday, and 10 more today. So in this case, what we do, we just increase the number of sold items in the, if you are maintaining for the week data or month data or whatever, no, it depends on the business requirement. So we, in that case, if we are handling this as a delta data or the incremental data, we just merge the data, or we do the upsert operations. So when I say upsert or the merge, what happens is, based on these IDs, we do the insert. If we don't find the ID particularly coming from source, and the destination bucket, like our landing merge doesn't have that ID, then we do the insert. Otherwise, we update the existing ID with the new value. So this kind of data load is the incremental data load. Otherwise, we just replace the whole table. In other scenarios, we just do some append operations also. It's just an insert. So whatever the data we have, we just insert the data, and we are done with it. So in such cases, when we are doing some append operations or the inserts only, the best practice here is to have some partitions based on some conditions. The most used partition is to have, if it is a daily batch processing, then we do a process partition based on the date. Or if we are doing this batch every 12 hours or 6 hours maybe, so in that case, we do this data partition based on the timestamp when we started the processing. That will be our partition. So on top of this, we can also create some metadata. So as I told you earlier, even we are handling the placing the data in our data lake. So data lake is nothing but, it's not as structured as when we compared with any data warehousing solutions or DBMS system. So it is not organized, it is unorganized data. But we can create metadata on top of that, and we can use the unstructured data as structured data also. So for that, we will have multiple data management, metadata management tools come to the picture. For suppose glue data catalog, or if you heard of Hive table, which is a famous uh, data management, I would say, or the data processing also, we can say, uh, tool, which is a RDBMS layer kind of thing. It's not 100% RDBMS though, but it is a RDBMS layer on top of HDFS as a data lake. So I'm talking about the Hadoop system. So in Hadoop, what we do, we will store all the files. You can draw parallels between this S3 bucket here, or Azure blob storage, and also the HDFS in the legacy Hadoop environment. So these are the data lakes. On top of these data lakes, we can create some metadata. We can create a metadata, and that will be maintaining in one more database like MariaDB or any kind of legacy RDBMS systems. So what I'm referring to here as a metadata is the DDLs. So even though we are not constraining our data lakes to have a particular schema, we can still access the data as a tab, as a table, because that is convenient to do any analysis or any data transformations or anything. So we can create a tabular format on top of the unstructured data also. Uh, so here the latest developments are the a few years back we also have some something called Delta Lake. So Delta Lake is nothing but the built upon the data lake concept, and it will give you all the features of the RDBMS. So the ACID properties. So basically Hadoop or the HDFS is write once, read multiple times. Principle. It follows the write once and read multiple times principle. So if a row is written to HDFS, it is not we will not be able to update the data in that particular row. So what we that is a problem, right? So if we want to do some upsert operations, what we need to do, we cannot update the existing row, right? So in that case, what we used to do in a few years back, read the source data and also the write data, source data and the target data, and to do the merging we used to create some temporary table, and then this temporary the target table will be replaced by the temporary table. So what we are getting all the if all the data from target and source, and then doing some union operations and doing some left anti-join to figure out whether that is a update or it's an insert. Based on that, we are going to replace the target table or the target data set using this temporary table. So it takes a lot in memory operations than just doing any merge operations. So after a few versions of Hive, we also had that acid property to the Hive table. But again, it is not that performance efficient. And also, if you are trying to read the table from Spark, it is not performance efficient. So we used to call the transactional table, but it is not that performance optimized. So because we are again having a RDBMS layer on top of the Hive table, and we lost the purpose of doing this distributed computing where, so it comes to one driver node, and then we are processing it in the memory if we are using Spark. So to avoid or to make this better, Apache came up with the Delta Lake. So Delta Lake is nothing but it will enable you to have ACID transactions on top of a Parquet file. So that can be the Delta Lake or the Delta tables can be used in the landing merge zone. So we get data from our source to pre-landing. From pre-landing to landing, we do the sanity checks, whether the number of rows are accurate and the schema is as expected. And then based on the um, mechanism, we follow that truncate and load or incremental or the append or insert thing. We are done with our landing merge zone. So once this is done, what we do, we bifurcate the data into some meaningful divisions, kind of data marts, we can say. If you know the data warehousing concepts, from data marts are subset of the data warehouse. So we can have market data mart, sales data mart, or the finance data mart. You know, that is nothing but the logical division of the data based on the business focus of business insights that data has. So this is a logical partitioning layer, I could say. And also, for suppose while our source data source generators using some technical names of any field, that might not make sense when we are sending this data to our end users or the business decision makers. So uh, in that situations, what we do, we rename the fields also in some cases to make more sense. And also, for suppose we have some sales data coming from one data source, and marketing data coming from another source, and some other team is processing the marketing data, and we are handling the sales data. So in this case, we need these two data sets, right? So this is kind of the aggregation layer, the unification under the aggregation layer is the common area where all the other teams also put meaningful data in this zone. So when I say the common zone, uh, all the other teams will have the same setup like sense layer, but their data source may be different from our data source. So everyone will finally put the process data in the unification layer, and only the required data will be accessible for that particular team. So if we are two teams, marketing and sales, and from marketing team we only need some two or three tables, and we don't need any other table. So this layer will do the necessary security kind of thing. So our team will only have the read access, or the uh, any kind of access level. We only get that kind of access to process the data, the read data from our unification layer or the aggregation layer. And further, we can also refine the data based on some more business logic. You might not need any what do you say, you might not need some data for other business use. For suppose, let's take what do you say, some alternate. So if this is one part, let's take an example of uh, any what I can say, um, some flags maybe, whether that flag, based on that flag, we decide whether this data is needed or not. So if that data is not needed and it doesn't make any sense to our final business, then we filter out the data, and we only put the required data to our refinement layer, and from that refinement layer we do the publishing. So so after this unification layer, we only have the required business data, and that data will be pushed to the publish layer. In the publish layer, we might have some other further logical divisions. This From this, we our data scientists or data analysts may do some data, they might run some machine learning models, like if we have some time series data, we if we want to do some forecast, so we apply some data science model on top of that, and then we publish that to our final database. So if you see in here, it is our AML out database. So this data we share, we create some reports on top of the data, and we visualize that data using some Power BI or Tableau or any other ClickSense, any other visualization tool basically. So this is our final reporting layer. And we in some cases we might also need to push this process data back to some other systems, like in same SAP or other SQL server and different things. Maybe our business users are running reports after they filter further and then create some reports on top of that. So for this we again put the final data to other targets. So here, as we are as our data is traveling from one layer to another layer, and there are so many different checks, and there are so many data enrichment and data filtering and refinement is having. So to make sure we are not missing anything, or even if we are missing some part of the data processing, we need to know where something is failing. So we need to trace back. So what is the issue with this particular data which published to our final database? So for that, the best practice is to maintain the data lineage. For suppose when I say data lineage, we have our data source, and then it goes to the pre-landing, then it goes to landing after sanity checks, and then it goes to merge, and then we we divide the data into logical parts and put this in unification layer, and finally we do the publish. So this is the data lineage. So if I want to understand how a table in publish layer is being created, so what is the source for this? So I need to know what is the source for this table. For that, what we generally do in one of the projects, when we are defining the pre-landing schema. So I mentioned we can create a table on top of the data set or the file we have in our data lake, right? So that metadata table, while that table, while we're creating the data definition, we can put what is the data source. Like we can create a source properties of the table. So let's take, there is a table one in pre-landing. So this is coming from our source. So here we put source is table one, and in landing zone, we have the same table one, but the source will be pre-landing dot table one. So let's consider this pre-landing zone as a database again, and these are the schema per se. Pre-landing as a schema in a traditional data warehousing, and we put we refer the table in pre-landing zone with pre-landing dot table one, and in the landing merge zone, we'll have the same table, but here the source will be landing. So like that, we create how many layers of data we are sending. Based on this, we will have all the properties created using the DDLs. So once this is done, we use a tool kind of TIBCO, EBX, or any other data catalog maintenance tool maybe data catalog in the cloud providers like AWS, Azure, and also GCP. We have cataloging tools. So using that, we read this property of each and every table and maintain this data lineage. So in any time, if I want to know where this data coming to this unification, then I know it is coming from this. Or if we are doing some joins, we can put the source as table in pre-landing 1 and also table in pre-landing table 2. So we understand, okay, how this table in landing merge per se is created. It is created using in the landing zone, how this table is created. So we will know this table is created by joining table in pre-landing, the table 1 in pre-landing and table 2 in the pre-landing. So this will makes this adds sense how the table in landing zone is created. So this data lineage will help us understanding how the data is transformed and how it you know traveled, I would say, from one point to another point. So yeah, so for that we use data catalog and data to maintain the data lineage. And as I mentioned, the metadata or meta store, we have the glue or MariaDB or any other DBs to maintain the DDLs and stuff in the metadata management. And so once this is all done, like this is the data engineering process we do generally. And to support this, we will also have Devops, the CI/CD orchestration, right? So so here what I'm trying to convey is the day-to-day work of a data engineer. So when we get uh, our tasks, maybe from ADO or what do you say, from any tickets we get to work on some tasks. So in that case, we get the tasks and then start working on the code part, maybe a Python code, a PySpark, or Scala or whatever code. Then uh, we will commit our code to the repository. So the code repositories, let's say GitLab or ADO. And here we can have multiple branching strategies. One of the branching strategies may be based on your team or the features you are working on. You were a lead, or if you are lead, you create a feature branch. And once you done, first of all, you will have the task, and you do the code development according to the tasks given. And then you commit your code to your own user branch. And from the user branch, you raise a PR, or pull request or the merge request to the feature branch. And once that feature, the code is reviewed by your lead, it will be merged to the feature branch. And from the feature branch, there will be one more branch called develop branch. So this is the develop branch from. So you might be knowing, or I can tell you how the development environments are, this setup, the whole project setup looks like. So first we do the development in our dev environment. And then this once the our unit tests and everything is passed, then we migrate or deploy this code to QA or UAT environments. And from after we get all the sign-offs, and we get user acceptance for this particular feature, we deploy this to the production environment. So to do this, we just commit our code. And then to commit this code and make so as we okay, in a big organizations, there are multiple users or the multiple developers working on similar code base, right? So to avoid any merge conflicts and stuff, we will have this branching strategy, just like I was explaining, to have uh, a user branch and then feature branch, and from feature branch we will have a develop branch. So from this develop branch, we deploy this code to our dev environment. So when before we deploy, we do some code build. So in the code build, what we do, we take the code and also package that with all the required jar files or the wheel files or the other resources needed, using Jenkins. Mostly nowadays, this build pipelines are also available in GitLab or Azure ADO, so on. So we do this build, and then we also deploy the jar file or the wheel file to the further environment like U8. Once so develop branch, from develop branch we deploy that to our dev environment, and from U8 branch we deploy it to U8 branch, or master branch to our production, or based on the project, we the branching strategy may be a little different, but this is a most common pattern, to have a user branch and then a feature branch and a develop branch and so on. So just to make sure, as many developers are working on the same repo, to avoid code conflicts and maintain the repository, we will have this branch strategy, and then we do the deployments. So and there will be another tool we can use as a Sonar Cube, or anything. So this will make sure there are no uh, uh, what do you say, to have a, sorry, I see a hand raised. I think you can go on.
Sir, you please continue.
Okay. Yeah. Oh, okay. Sorry. So you are not able to see the notepad. Okay. Okay. I can give you the. I'm so sorry. So yeah. So when I was talking about the data lineage, I was presenting this part, like in the uh, data lineage part, we get data from data source, and then pre-landing, and we the data goes till the published layer. So in this case, we need to have track of how the tables are getting created, what is the source for that. So for that, we define what is the source for each and every table in the DDL, as a table property. And from this information we give while we create a DDL, data catalog, are the are the data lineage maintenance tools like TIBCO EBX. It will generate this lineage by reading this table properties. So that's what I was explaining. My bad, I didn't realize that I was not sharing this. So yeah, going back to uh, this presentation. Hope you can see the presentation now. Yeah. So yeah, I was explaining about the Sonar Cube, right? So this will help you to avoid if there are any code vulnerabilities. This will check whether the code is in the accepted standards. Let me give you one example. Sometimes it is not recommended to have some regular expressions in a code. So such kind of code vulnerabilities will be checked by SonarQube, and when you run a report are on top of the code repository, you will see all the code vulnerabilities in the report, and that will give you insights to make your code better. And you rewrite the code, and also then commit the changes, and then you deploy it to the production. So this is the use of a tool called SonarQube to minimize code vulnerabilities and stuff. And also you will have some code coverage. When I say code coverage, it this concept comes when if you are trying to do some unit testing of your code. So what we do in the unit test, I think you might be aware of that, but let me give some high level what we do in unit testing. So when I say unit testing, we make sure when we execute this code, each and every line of that code is reachable when we pass some various conditions. Let's take one example of an if loop. Um, Let me share this. So let's take an if condition in our code. So if and only if we check, if and only if we check with this condition, then only we will be able to see whether this line of code snippet is getting run or not. So we need to make sure when I run my job in any condition, it should run the respected code snippet. So condition 1 is passed, then we may always go to this code snippet, and we might not get any data which goes to this else part. So that may be the business data, or the business requirement, or the data we get from our source. But as a developer, what we need to make sure is our code is reaching each and every line. So that's when the code coverage comes. So we write unit test cases in such a way our dummy data, or some mock functions we use to cover all the code in our script. So we create these conditions, some imaginary conditions. We pass the data according to that, and using the unit test cases, we write for every functions. Like in Python, we write functions like this. So for every function one, we will have one test case. So and then we run the code coverage, and we define a code coverage based on the project requirement, or based on other standards. We define what is the best code according to the coding standards we define. For suppose, let's say 80% is the minimum code coverage we need to have to pass the checks in Sonar or in anywhere, and then only we deploy this code to our production. So that means at least 80% of the lines in our script is reachable. We need to make sure that is happening using our unit test cases. So that is code coverage. So yeah, and then we have Airflow for our job orchestration. When I say orchestration, it might be uh, uh, a schedule based job triggers, or it may be file triggers are the feed triggers. When I say feed triggers, if there is a new file coming in, then we need to run our job or the pipeline or the process, whatever we are doing this, all the data processing, right? So based on one single file, for suppose our data upstream or the upsource, sorry, yeah, so our upstream is creating a job, a file at particular time, and when the file is created, then we need to run our process. So it is not, it is not based on the schedule time, but it based on the file which generated. So that is called a feed trigger. And a schedule based, yes, it will have a static time at what time we need to run this job. Based on that, it will continue running no matter whether we have the latest data or not, that is another thing. So for that job scheduling stuff, we need to orchestrate these data processing jobs. So that is what we do using Apache Airflow. We create some direct acyclic graphs, the DAGs we call, and we will have multiple different operators to call the processes, whether that is a Databricks process, or we use some bash operators, we use some Python operators in the Airflow to call this various uh, um, the job, calling the job to start running. So that is what we use Airflow for. And then there is a artifactory we call JFrog artifactory. So it is similar to the GitLab. So GitLab is to uh, do the versioning and control that versioning for code, and this artifactory is basically to store and manage our packages, like wheel files or the jar files. For suppose in an instance, we have deployed our solution to production, but that is breaking something and we need to revert that change, right? So in such cases, this artifactory comes into the picture, and we know what is the latest deployed package to the production, and that is causing some issue. So what I need to do, I need to revert that. So let's say version 2 is in the production, and I want to go to version 3. In that case, this JFrog artifactory comes into the picture, and we redeploy the version 1 to the production, and everything go smooth. And meanwhile that is happening, we work on some hard fixes and then deploy the code. So that is a general practice, or the general process we follow. And data governance and security and logging, we use different things like CloudWatch, to govern um, the resources. So how much time it is up, and uh, uh, for suppose if we are maintaining some resources in the cloud, after some time, some idle time, we need to stop that particular resource. So in that case, this comes into the picture. And for IAM roles to have appropriate access permissions to some resources, and in the same way, Azure Active Directory to have permissions to the developers in our team. And KMS is uh, uh, security, data security, right? The public and private key concept. So it applies that private and public key concept on while you read data from your data store and do some processing. So we use some KMS keys to authenticate something and stuff. So yeah, so this is most of the you know tools and tech stack we generally use in any data engineering project. So this is one kind of batch processing, or some kind of near real-time data processing as well. But I can show the Lambda in a quick time. But yeah, before that, I'll just check this. Okay. Sorry. Yeah. So once the batch processing is done, we as I mentioned in the starting of the session, we will have the best of these two, the batch processing and also the real-time processing. This is a hybrid of these two. So we will have data batch processing for doing some analytics after we get the real-time data, and also at the time while the data is in transit, we do some analytics and do some data visualization stuff. So in this Lambda architecture, you will see two different paths. So if you observe, there are two different arrows. If you observe, there is a red path and there is a green path. So this red path is called a hot path, and this green called cold path. In the hot path, what happens is, this is the live data streaming. For suppose there are some log analytics, the same old example. So we get this log data every few seconds, and then we put that in our Kafka topic, let's say. So Kafka is a messaging queue. It works on the publish and subscribe protocol. So like you can consider this as YouTube. So any user or any publisher can publish their content, and any subscriber like us can see at our convenience, right? In the same way, Kafka will accommodate the real-time data whenever the publisher publishes the data, and then the subscriber will read the data whenever he needs the data, or as soon as it comes. So that is a completely different topic, and it's an interesting topic to have handle real-time data. So yeah, coming back to the topic, like yeah, here we are using NiFi for data ingestion. So we read the log data from our website maybe, and then we publish it to Kafka topic. And from Kafka, we are using a Spark structured streaming. So if you know what is Spark, Spark is a processing engine, as I mentioned earlier, which is similar to Databricks, or Databricks is similar to Spark on cloud. So yeah, so in Spark, there are multiple APIs to handle batch processing and to handle graph data, and also there is mlib to do the machine learning process machine learn to create some machine learning models and do the processing stuff. There are APIs. In the same way, we have an API called Spark Structured Streaming to handle the streaming data and also have some structure on top of it. So even if you are getting this log as a file and unstructured or semi-structured data, you can define the schema, and while you are doing some analysis in the processing in your Spark, you can do the processing as a structured table, or just like any DBMS table. So that is what the Spark structure streaming will give you as an advantage. And from that, you can have a database like NoSQL database. I mean, that is efficient to handle some live or the real-time data like Cassandra, HBase, or MongoDB, various business needs and various databases. So based on that, you will design this architecture, right? So in here we are using Cassandra for that, and from the Cassandra we create live dashboards. Let's say as we are talking about the log analysis, maybe in last 1 minute how many users are active in the website, right? So that may be one query, and we just create some pie charts or the bar graphs or something else, and we visualize that to our final reporting. That's what we do, the analytics and the on the go, like the real time. In the same time, we might need to create some weekly reports or monthly reports or the yearly reports, right? For that, while we do this real-time data processing and real-time data visualization, we also store the same data into our data lake and do the processing after this after some time. Maybe it is a batch processing again. So in the real time we are publishing these results, how many users are active per every 1 minute or 2 minutes, and we also have one more chart to indicate how many users were active last day or last month. So that query that visualization we do with batch processing. So here we are combining uh, these two jobs, batch processing and also the real-time processing. So this is a high level overview of Lambda architecture, uh, and then I'll move forward. This is I mean, nothing much to explain. This is self-explanatory. Um, so I try to put what are the parallels you can think of in three different cloud providers, like in the famous cloud providers like Azure, AWS, and GCP. You can see for ingestion what type of tool you can use in Azure and AWS and GCP. Maybe IoT hub in Azure, IoT in AWS, and cloud IoT in GCP. In the same way, for data lake, you can use your data Azure data lake service or the blob storage for your object stores, and the alternative for AWS alternative for that is AWS Glacier and S3 for object store. In the same way, GCP has cloud storage. So yeah, for visualization, there are preferred tools like Power BI in Azure, QuickSight in AWS, and Data Studio GCP. I mean, there are various other tools, but these are the preferred data visualization tools offered by these cloud providers. So yeah, I think I'm open for questions, and I would like to answer if you have any questions.
Hello, sir.
Yep.
Sir, you can find the Q&A in the Q&A part, the questions.
I'm sorry.
You can find the Q&A section.
Where can I in not in you Q&A? I think I didn't get you. Okay, this is
Yeah, answer section. In the answer section, there are 4 questions.
okay, fine. Okay, so for this question, yes, you are right, Shiv, Parshav. Yeah, there are very little, but there are websites which are conducting hackathons for data engineering also, but also in org level there are many hackathons. You just search for them, and if not as much as you find for data science hackathons, there are data engineering. But yeah, you are right, the number of hackathons are less for data engineering. But yeah, you still can have hackathons. Okay, so data lake and data warehouse are fundamentally the structured and unstructured. So data warehouse will accommodate structured data. It doesn't support unstructured data, but we are calling after we refine the data, and I explained, right? Even from the data lake, we are creating table structure on top of that. So you can use the data lake and the metadata combination to have your data warehouse as well. So fundamentally, data warehouse will have all the structured data, and data lake will have all the unstructured, unprocessed data. So you just pull some file and put it in the data lake. Unlike, you need to define some structure, the DDL, to store your data before you put your before you insert the data into a table in the data warehouse. So that is a fundamental difference. And when I talk about data lake, like NoSQL database like HBase or Cassandra, it doesn't even ask you to have any schema at all. It will support the data evolution, the metadata evolution. So what it means is, for suppose you initially thought of having only 4 fields in the file, but someday you got some 5 fields, or maybe a different data type as well in that particular file. It will still accommodate and it will not break. Whereas in RDBMS or data warehouse solutions, it is very much particular about the schema and data types and everything. So you need to have structure before you put your data in your data warehouse. Hope that answers the question. Why the data loss happens from data vault to pre-landing zone? Any particular scenarios or examples? Yeah, this is a good question. So maybe that is a transient issue. Maybe while they send as a packets, right? The networking concepts basically. Sometime when the data is sending as a packets of data, you might miss some data. So when we are handling RDBMS solution, it is either full or none. Like so I don't remember the sentence exactly, but either you do the full job or you don't do the job. But in networking, we might see some partial data transfer happening from one edge to one source to another destination, right? So in that case, just to make sure we are not losing any data, or in some cases we might do some duplicate data. So if some jobs are what do you say, are triggered multiple times by the users, or developers or something in production by human errors, the data ward might send the same data file again. In that case, we see some duplicate records, right? So that is another case I could think of. In that case, we will be finding the mismatch using the metadata file. Yeah, landing area is same as staging area. That is, yeah, that, I mean, it is relatable term. What is the need for separate landing merge area? Yeah, correct. So Delta Lake, I call Delta Lake as a landing merge area. So simple thing. So the concept, what you understand is absolutely right. The Delta Lake I was referring is a landing merge area. Okay, so hackathons are nothing but you will have uh, uh, okay, so you answered that competitions. Yeah, maybe I can give some elaborations. Hackathon is uh, you know a competition where multiple developers, data engineers, or software engineers will compete to solve one particular problem. For suppose, let's take you are trying to solve a particular problem in your area, or you it may be you are developing a simple game, so it is based on some a game. So every game developers come into one stage and do their best work, and then view showcase your outcome of the outcome of your effort. So this generally will be a 24 hours hackathon or 1 week hackathon, or 10 days hackathon. So time bounded hackathons are these. So in that particular time you are going to solve a particular problem. It may be the problem statement may be given by the organizers, or they will give you some random categories, and you can pick one category and try to create your own problem statement and come up with an unique creative solution. uh, and the one of the best solutions and the best problem having best solution will win the hackathon. Hope that answers. What is data lake is used when we want to do after storing? Oh, I didn't quite get this question. Data lake. So data lake is the first stage. Oh, I didn't quite get the question. If you are there, can you rephrase your question, Ronak? Okay, if I can relate that, I can give you one example of Snowflake. I was talking about earlier. Uh, so in data, so we will get our source data in the data lake. On top of the data in the data lake only, we will create metadata tables in Snowflake and then do the transformations. So this is kind of ELT. I think you're referring to ELT. So what is a use of data lake in ELT? I'm considering your question as that. So yeah, so you can have you can create metadata or tables on top of the data lake and then do your transformations. So yeah, I hope that answers the question.
I would like to request all the attendees to fill in the poll about the feedback, as it helps us to conduct more such sessions. Thanks a lot, Pavan. On behalf of Analytic Vidya, I would like to thank you. I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
I'm
I hope
glad
you
to.
guys have, yeah, thank you. I hope you guys have filled in the feedback poll. If not, I request you to please fill in the poll about feedback, as it helps us to conduct more such sessions. If you wish to conduct a webinar or facing difficulty in registering, connect with us at editor@analyticvidya.com. The recording of the session will be available within 2 days on our YouTube channel, and the YouTube link is given in the chat section. We will be back with another session of the data hour. The link is in the chat. Till then, bye bye and keep learning.